All right, so we've got the lesson on volume of prisms and cylinders. Volume of prisms and cylinders. All right, so when you think about volume, now all of a sudden we have to go from 2 dimensions to 3 dimensions, right? Volume is 3-dimensional. Area 2-dimensional, right? Even a 3-dimensional shape for surface area is made into a 2-dimensional figure. But volume is definitely 3 dimensions, and really the idea of volume is how many cubic units it takes to fill an object. So if you look at my example here of this cube, if you look at this first cube here, see that cube? All right, so that's cube number 1, right? Here's cube number 2, number 3, number 4, number 5, number 6, number 7, number 8, number 9. That takes care of that top row. And then there's another 9, right? So 10, 11, 12, all the way through 18 in the middle row. And then you've got another 9 in the bottom row. What's the volume? 9, 18, 27 would be the volume of this cube. 27 cubic units. So a volume is the number of cubic units to fill up some kind of 3-dimensional closed figure, all right, or figure. So volume, all right, so volume of a cube is going to be what? Well, length times width times height. You can do it that way. But please remember, when dealing with volume, we want to think about the units. And so what are the units for volume? Well, if you're in inches, it would be inches cubed, right? Inch by inch by inch. We'll murder the bomb, right? That's old time. All right, sorry about that. Inches cubed, right? If we're dealing with feet by feet by feet, feet cubed. If we're dealing with miles by miles by miles, miles cubed. Hey, even furlong is a unit of length, furlongs cubed. Metric, centimeters cubed. Millimeters cubed. Meters cubed. How about kilometers or kilometers cubed, depending upon your pronunciation? Potato, potato, tomato, tomato. Let me remind you of one thing. What you must do, though, is make sure that all your units match. For example, look at our cube here again. Let's look at that center right there. If I had a unit here of 1 foot, but I had a unit here of 12 inches, right? And then the depth, which you can't see, which is also, let's say, in 1 foot, then I can't go length times width times height 1 times 12 times 1. That wouldn't be true. I have to get my units to match, and so be careful there, all right? Usually the higher up in your math you go, the more they'll deal with different units and converting them, but that's always a possibility, and it's something you have to be aware of. All right, so what is the actual formula for the volume of a prism or the volume of a cylinder? Well, a cube is a special one, because remember, a cube, the length, the width, and the height are all the same value, and you could actually just go side cubed. Length times width times height, or side cubed. Well, what about any prism? What about any cylinder? What's the formula for that? All right, so let's take a look here. Oops, sorry about that. So let's take a look here and make sure that we understand what's going on. All right, so formula. It's pretty simplistic. The concept is take the area of the base and then multiply it times the height. So let me go back to this cube right here. The area of the base, sorry about that. So area of the base. So I have 1 unit, 2 units, 3 units, 1 unit, 2 units, 3 units. So the area of the base would be 3 times 3, or 9 units squared. And what's the height? 1, 2, 3, 3 units. So what's 9 units times 3 units? 27 units cubed. And isn't that what we got? So what is the formula for the volume of a cylinder? Area of the base times the height. And be careful, because again, sometimes they'll tell you the area of the base. They'll use a capital B to signify that. And so you have to be aware of that if the problem gives you that kind of a situation. All right, sorry, I keep jumping there. It's my Windows 10 not liking what I'm doing here. All right, so be careful. If you know the general formula, area of the base times the height, then you'll make it specific to the certain kind of prism or to the cylinder. All right. What if you have a prism with a for a parallelogram as the base? Well, now what's the area of the base of a parallelogram? Well, it's base times height, and then of course times the height, right? So area of a parallelogram would be the area of the base. What's the area of the base of a trapezoid? Do you remember the formula for area of a trapezoid? All right, and actually, I'll do 3 first, being I already started. Area of a trapezoid, 1/2 base 1 plus base 2 times height. Over here to the right to number 2, you remember the formula for area of a triangle? Come on, be thinking. Don't be a copier. Be a thinker. All right, what's the area of a triangle? And hopefully you're saying 1/2 base times height. And then do you remember the formula for area of a circle? Remember, pies are not round, they're square. No, the opposite way. Pi r squared, right? Okay, so if we'll use those specific formulas for the area of the base, we'll be able to get the volume of a cylinder or a prism. But I would remember the general formula, area of the base times the height, and that'll take care of everything. You'll think about each individual shape. Okay, so again, we got to make sure that we understand what the base is and what the height is. What is the base? Well, the height. The height, like always, is the perpendicular distance between the bases. It's the perpendicular distance between the bases. So, to find the volume of a cylinder, we're going to do area of the base times the height. And you can see that our height here is perpendicular to the base. So this prism, area of the base times the height, and that's going to be our height. Our triangular prism, area of the base times the height. No matter how the figure is sitting, remember the bases are always the 2 congruent opposite sides. Okay? And we'll make it specific to the formula. Well, let me show you some problems. All right, so first off, we look at our first problem, and it's the volume of a cylinder. Okay, well, we're going to find the volume of a cylinder. So I would look at that, and sometimes the problem will say a cylinder, other times it'll just give you the picture. We have to look at that and say, hey, that's a cylinder. All right, hopefully you can do that. We're going to start off with our general formula. Again, this is what you should write. This is how you get started, right? Volume of a cylinder, area of the base times the height. And then make the specific formula. What is the area of the base of a circle? Pi r squared times the height to get our volume. Now, let me again try to show you what volume is. All right? And again, I can't draw, so excuse me for this. I'm just terrible at drawing. But if I put a cube in here, all right, that looks a little bit cubic. I'm terrible with that. But if I put a cube in here, right, I want to try to figure out how many of these cubes can I fit in here, right? Right? How many of them fit in here? And you know, again, it's and I got to go higher as well, and you know, I got to figure out how many I can fit in here and how many of these cubes, and I got to fill up this whole thing, right? And because it's circular, I'd never be able to do it in this methodology, but that's the idea, right? Get the idea, right? So I got to figure out how many, so I'll just use the formula. All right, so let's just run the formula. So volume, pi 3.14, use the pi button if your teacher wants you to use that. What's our radius? 6 feet, and remember it's pi r squared. And what's the height of the whole? It's that 9 feet, so times 9 feet. Now it's just a calculator problem. Remember, order of operations, evaluate all exponents first, then multiplication, division, left to right, addition, and subtraction, left to right. 6 squared is 36. I'll multiply that times 3.14, and I'll multiply that times the 9 feet. All right, and hopefully you're punching it in your calculator as well, and you punch all this out, and we've got 1017.36 What are our units? Cubic feet, feet cubed. Now, my advice is your work should look like this for every problem. You should start with the general formula. You should then go to the specific formula. You should then show the subbed in values. You know, if your teacher sees this and you somehow punch something in wrong, you might get some partial credit. You are demonstrating that you know how to do the problem, and it's also written so that you also know what you're doing yourself. All right, so that's how your work should look, and that should get you where you need to be. All right, let's do another problem. Let's do another problem. So this one, find the volume of the prism. And again, sometimes it won't say what the shape is. You have to look at that and say, oh, that's a prism. And I'm finding volume, so general formula, again, area of the base times the height. And let's get specific. What is the base? It's a rectangle or a parallelogram, so it's going to be base times height, right? And then times the height, sorry about that, times the height of the whole shape. Okay? All right. If you'd like, pause the video. You can run the numbers yourself. All right, so volume. What is the base? 5 centimeters. What is the height of the base? See how there are two heights? So remember, this is area of the base. So this is base height. And then this height is the height of the whole prism. So times 10 centimeters. So what have I found in my teaching? I've found that my students forget one of the heights. But you shouldn't do that if you write this. What have I found in my years of teaching, 31 now? That students don't write this step. And guess what they often do when they don't write the step? They forget one of the heights. You want to be that person, right? Don't be that person. All right, punch it out. 5 times 7 is 35 times 10. Okay, we can do that in our head. 350. And what are my units? And again, notice I have units, units, units. Centimeter times centimeter times centimeter is centimeter. Oops, come back. Oh, brother. Is centimeter cubed, right? So we end up with centimeters cubed. And that's my solution there, and that's my answer, right? 350 centimeters cubed. All right, let's do another one. All right, on this one, let me do this first off. So what kind of shape is that? What kind of shape are you thinking? I hope you're thinking prism, right? Okay, let's find the volume of that prism. Start with the general formula, right? Area of the base times the height. That's not hard to remember. It's the same for all prisms and cylinders. Now let's get specific. What kind of base is the base? Clearly in yellow, right? It's a triangle. Do you remember the triangle formula? 1/2 base times height. And then again, times the height of the whole prism. Let's run the numbers. All right, and if you want to do the problem yourself, why don't you pause the video? I'm going to come off here to the right. So volume, there's my half. What is the base of my triangle? Do you see how it's the 4 meters? All right, so 4 meters. What's the height of my triangle? Do you see how it's the 5 meters? Okay, and now times the height of the whole prism. You say, but Mr. Scarfy, is that the height? Sure. It's just the prism is laying on its side. It's not standing upright. Don't let that throw you off. Remember, the height is always the perpendicular distance between the bases. Okay. Calculator, this one's pretty easy. Half times 4 is 2. 2 times 5 is 10. 10 times 8, 80 meters cubed. Again, I've got my units in there, so I don't forget my units, and we're ready to roll. All right, one last one. All right, so let's take a look at this. Look at all these boxes I have. All right, I got to get rid of these. I don't know where they came from. We got a ton of them. All right, let's get rid of them. Oh, brother, I got a few more here. All right, I'm finally there. So what kind of shape? What kind of shape on this one? So it's a prism. right? See the congruent bases, and what kind of shape is the base? I hope you're thinking trapezoid. So we have trapezoidal bases. So this is a trapezoidal prism. All right, so it's going to be volume of a prism. Formula: area of the base times the height. Again, be careful. We're going to use a specific formula. So again, please note, here's the area of the, here's the area of the base, right? This is the height of the whole prism. You gotta keep it straight. All right, you gotta keep it straight. Let me get a little bit more room behind here, so let me extend up. Okay, so let's take a look here. Volume, 1/2. Do you remember how to do the area of a trapezoid? Well, remember, one of the parallel sides is base 1, and the other parallel side is base 2. And it doesn't matter which one's 1 and which one's 2, they're interchangeable. All right, do we have the height of the trapezoid? Well, we don't see it here, but remember, they're congruent. Do you see it there? Okay, so remember, the height is the perpendicular distance between the parallel bases. So we got a 3. And what's the, so the height here is 3. And what is the height of the whole prism? It's 8. And we're ready to roll, right? So 7 plus 4 is 11 times 3. And if you want to do a half times 4, or half times 8 is 4. And therefore then we end up with 11 times 4, 33 times 4. Just punch it out in your calculator. All right, how about 11 times 3 times 8 equals, divided by 2 equals 132. And do we see any units? So do you remember what to do when you don't see units? Yeah, units cubed, right? 132 cubic units. Area of the base times the height. So again, let me go back to the beginning here and just review. When you're dealing with volume, you're dealing with how many cubic units fill some kind of three-dimensional figure. We're going to use area of the base times the height, but be ready for specific area formulas. Parallelogram could be a square, right? Sometimes square, we could use side squared, right? The shortcut, or base times height. Could be a trapezoid, could be a triangle, could be a circle, right? Or they could give you the area of the base with a capital B, and they'll do that sometimes. That's an easy problem. Whatever the value of the capital B is times the height of it, and it'll give you the volume. All right? So volume of prisms and volume of cylinders.